Hi everyone. In this video, we are going to see the difference between open loop and closed loop system and what is mathematical modeling. What is open loop system? Any physical system which does not automatically correct the variation in its output is called open loop system. Or I can say the control system in which output quantity has no effect upon the input quantity. Means this particular system is having input and output, there is no feedback. It is basically an open loop system. What is closed loop system? An open loop system with a feedback is called as the closed loop system. A control system in which the output has an effect upon the input quantity. In such a manner, we can maintain the desired output value. This is the reference input. You have a plant of the system. If the output is different or differing with respect to the reference input, this controller will be activated by the feedback system and it will control the plant so that we can get the desired output. Let's see the example of the open loop and closed loop system. In open loop system, the control action is independent of the output. Since there is no feedback here, you see a toaster is one example. We have an input that is a set time. Timer is set for 3 minutes. The toaster is operating for the 3 minutes. You will get the output. It's a toast. Here the toaster doesn't check how brown the toast is. It's just run for the set time. Let's see another example, a traffic light. It is a fixed timer. Input, it is a preset time. The traffic light changes after the fixed time. For an example, the traffic light does not sense the number of vehicles and it changes after the preset time. And the main point is the open loop systems are very simple and inexpensive, but it cannot correct the errors. When we take a closed loop system, the control action depends on output. Since we have a feedback, room thermostat, it is an AC. It's an example, a set point. Desired temperature is there. If it is getting changed, then you will measure using a sensor and you have a controller that will send a control signal to maintain the desired temperature as 24 degrees Celsius. What is the point to remember in a closed loop system is the closed loop system is more accurate and it can correct the errors. But it is a complex and costly system. Let's see the difference between open loop and closed loop system. The open loop systems are simple and it is economical, whereas the closed loop system is complex and costlier. and the open loop system is inaccurate and unreliable, whereas the closed loop system is more accurate and it helpful for automation. Because of the feedback, the gain of the system is getting reduced in case of the closed loop system, but the gain reduction is not a problem in an open loop system. The main point is the changes in the output due to external disturbances are not corrected automatically in open loop system, whereas the changes in the output due to external disturbances are corrected automatically in a closed loop system. Open loop systems are generally stable systems, whereas great efforts are needed to design a stable system in a closed loop system. So let's see modeling in control system. What is basically a model? Model is nothing but you have a plant of the system. You are going to represent in a mathematical way. That is called as modeling. Model is useful for analyze the input output of the system. There are different mathematical models we have. We are going to discuss in future videos also. There are three different models. One is differential equation model, transfer function model and state space model. Let's see these three things in detail. First, a differential equation model. It tells how system changes with time with the help of the equations. Imagine a car. You are having an accelerator, then the car will move. That is, the speed, acceleration and position will change with respect to time. As a summary, the differential equation model describes the behavior of the system. Let's see the transfer function model. It gives the relationship between input and output. You are having a fruits. You are giving that input to the system mixture and you will be getting a juice. You are not worrying about what is happening in this system. That's why the transfer function model will give a mathematical relationship between input and output. The third one is state space model. Here you have a driver in case of a car. There is a position, speed, acceleration. Everything will change with respect to time. Then you will get an output. Means that it tells what is happening inside the system at every instant. Another example to understand, consider a human body. The doctor checks the heart rate, temperature and blood pressure. These values tells the current condition of the body, which we will technically call it as a states. State space model tells the complete internal condition of the system, not just the output alone. If you see this circuit, the mathematical model is writing the equation, applying the KVL. Transfer function model, you are going to take the Laplace transform and you are going to represent like this. And this is a state space model in which you will be able to understand the internal components of this circuit. These are the references. Thank you.